Very good morning, students. Welcome back to the session on exploring pointers in C, the second day session. Today's session will be on pointers and arrays, continued by Professor S.S. Navalgunsar. Here, I hope in the previous topics that are covered, that the fundamentals of pointers in C, and we have started with the arithmetic pointers. I hope you got to know about the fundamentals of those pointers. Today, the session will be continued by Naval Gunsar for the next 2 hours. Now, I request Naval Gunsar to continue the session. Sir, please.
Okay, thank you, Kotesh. Thank you very much. Very good morning to one and all. It's once again nice to see you on day two of exploring pointers in C. So I sincerely hope that whatever was done yesterday was of some use to you, and I sincerely hope that you also have gone through the contents of last discussion. If there are any doubts, I'm just going to have 1 minute time now. If there are any doubts, please let me know. Otherwise, we'll start with today's session. Any doubts? Okay. So I think we'll start with today's session. So can you see the screen now? Kotrish?
No, sir, still not yet.
Okay.
Yes, sir. Sir, once again, can you please share the screen, sir?
Okay. Now?
Yes, sir. I'll just add it to stream. Yes, sir.
Okay. So
Sir,
this is
please
what we
continue.
have. Yeah. Thank you. This is what we have done in the last discussion. We have gone through the introduction to pointers, and then we have seen different parts of program memory, code memory, and stack and heap, and where exactly the memory allocation will be done for different parts of the program is we have. That's what we have seen. The twin operators, ampersand sign and star operator or dereferencing operator is also seen by us. The way in which we declare pointers like int star my ptr, and is it okay if I just put one star for declaring two pointers? All these aspects we have seen in the last class. Then we also have looked at the size of a pointer variable. We said the size of different types of data can be varying, they can be different, but the size of different types of pointers remains the same. It is because of the fact that we need to still hold the starting address of some variable in memory, and that's uniform irrespective of type of data. Then we have seen the concept of double pointers. That means a pointer to a pointer and the syntax for defining it. Then we have looked at the conceptual diagram where variable a is being pointed to by pointer p, which is a single pointer, and p is being pointed to by q, which is a double pointer. And then the concept of trip pointer also we have seen in the last class. We started with the pointer arithmetic, and we tried to see if it is possible for us to have addition of two pointers or subtraction of two pointers, multiplication of two pointers, and division, or is it possible for us to do some kind of operations arithmetic with respect to a scalar quantity. So we have looked at some valid operations and also invalid operations. Now we must start with this particular slide and then we'll continue. So the plan for today's session will be the remaining part of pointer arithmetic, and we'll also see pointers and arrays in the first part of the session, followed by a 5 minutes break, and then we'll continue with pointers and strings. So this particular diagram shows you an array which consists of some data, which is indicated as v of 0, v of 1, v of 2, so on and so forth. So this particular array can be of different types of data, right? Now in this case, I am assuming that the size of, let's say, integer is 32 bits. That means we are working with a 32-bit machine. So the starting address of first integer of this array is at 3000. So starting from 3004, we will have the starting address of second integer of this array, so on and so forth. So it's quite possible for me to initialize a pointer. In this case, I call it vptr, and initialize it the starting content here. Now, when I say vptr plus plus, it starts pointing to the next integer data in this array. So please understand, when I say vptr plus plus for integer array, now the starting address, if it is 3000, vptr plus plus will not take me to 3001. It will take me to the next integer in the memory allocated. That means the content of vptr will be now 3004, not 3001. Now, if I'm talking of a 64-bit machine, a 64-bit machine, so if I assume that the starting address is 3000, then the ending address would be, what is the answer? For 64-bit integer, what will be the ending address of the first integer in the array? If I assume that the starting address is 3000, answers in the chat box quickly. The starting address is 3000. So I'm talking of a 64-bit machine. Any answer we have? Okay, Rakshita says it's 3004. Deepak says it's 3008. Yes. So please note, the starting address of first integer would be 3000, and then the second integer would be at 3008. So the moment I say vptr plus plus, so vptr plus plus is going to get me from 3000 to 3008 if I'm talking of a 64-bit machine, a 64-bit integer, or an 8-byte integer. So it's very, very important for you to realize that when you do pointer arithmetic, the increment operation is not just by one, but it is by one integer data. So that's very important. Now, let me assume that I do vptr plus plus 3 times. That means initially the pointer is pointing to this particular data. Once I increment the value of vptr, I'm pointing to the second data here. Second time I increment, it is pointing to third data. Third time I increment, I'm pointing to v of 3, isn't it? Now the point is, can I do something like ptr minus minus? Can I do that? Well, the answer is yes. So if I do that, then once again, please note, if the starting address is 3012 for this particular integer data, when I decrement it, it is not going to be 3011. No, it is going to be 3008. It is going to be 3008. So this is a very, very crucial thing about pointer arithmetic you must understand. So it is with respect to this concept that we say I can subtract 2 pointers to find the length of the string. Now, if I assume that I have an array of characters or strings about which we are going to discuss very soon in the session 2 of today's discussions. So it's quite possible for me to say ptr2 minus ptr1, which will directly get me the total bytes present in the character array. It is also true even for the integer arrays or float arrays. So this is a very, very important aspect. Now I have a very quick quiz coming up. Now I just want you to go through this particular quiz and answer 1 or 2 questions. Now I declare an integer variable n, and let's declare a pointer variable int star p. So how to read this? I read p as a pointer of type integer, right? I repeat, p is a pointer of type integer, or p is pointing to an integer variable. Now we say p is equal to ampersand n. P is equal to ampersand n, and then we say star p is equal to 2. Now let me just stop at fourth line. Now please tell me, if I consider the first four lines, is this going to constitute a valid program or not? Yes or no? The answers in the chat box. If I consider just four lines, first four lines of the code, is it a valid piece of code or not? Can I say star p is equal to 2? Please recall from yesterday's discussions. Okay, do I have any answers? Okay, Srinji says it's going to get me n is equal to 2. Okay, let's see. Any other answer we have? Oh, Rishita says yes, it's perfectly valid. Bhumika also says yes. Please note that this is perfectly okay. Now, it is because of the fact that p is pointing to a data variable n. So please don't misunderstand saying that n is not initialized. So how do I initialize p to n? How do I make p point to data variable n? Please note, p is pointing to n with the help of the third statement. So because p is a pointer to a data variable n. Now the moment I say star p, it is one and the same. When I say star p, it means that I'm trying to force a data whose value is 2. Star p is equal to implies that the value which is stored at a location pointed to by p is 2. So that automatically gets me the value of n as 2. So this is perfectly okay. Now if I miss this star symbol, and if I simply say p is equal to 2, please note this is perfectly illegal. It is wrong. Sorry, because if I say p is equal to 2, it means that I'm trying to force an address. That is not okay. So I must be able to say star p is equal to 2. Now if I consider the last statement, star p is equal to star p plus star p, what will be the output? Any answers? Please get the answers in the chat box. So what will the answer if I say star p is equal to star p plus star p? Yes, well, the answer is perfectly right. It is going to be 4 because I'm just trying to double the value of this number. So please be familiar with this kind of construct also. So star p implies content of p, and the second star p also implies content of p. That means I'm trying to add it 2 times, and once again I'm going to store it back in star p itself. So this is perfectly valid statement. So please be aware of such kind of statements. Let's also look at some pointer assignments. A part of it was dealt by Professor Shrikant the other day, and also Professor Kotesh. So just for a quick revision, I'm going to tell you as to what this actually means. Now, if I say star int star ip, it means I have ip, which is a pointer pointing to an integer type. Char star cp implies cp is a character pointer, and dp implies a double pointer. Now, if I say something like ip is equal to dp, now please note that this is perfectly wrong. It's illegal because of, can you tell me why is this illegal? ip is equal to dp. Answers in the chat box. ip is equal to dp. This is not okay. Why? It is not okay because I have mismatch in terms of uh, the data type on both the sides of equality sign. So if you look at left hand side LHS, yes, Rishita says it. The LHS corresponds to an integer pointer, RHS corresponds to a double pointer. So we know the size of different types of pointers is same, but the size of data each one of them points to is different, isn't it? So when IP points to a certain number of bytes in memory, DP points to a certain other number of bytes, and hence this is not okay. So if I say DP is equal to CP or IP is equal to CP, that means I cannot actually assign a character pointer to integer pointer. So this is a problem with respect to the number of bytes each of these pointers addresses. So what is the solution? The solution would be to go for a typecast. Typecast. So when I go for typecasting, it tries to fetch appropriate number of bytes from memory, and then we go for manipulations. Okay. So there is one special type of pointer that we must be careful of. It's called a wide pointer. Okay, it's called a wide pointer. So why do I need it? I need it because it's going to act as a generic pointer. It means it represents any type of pointer. For example, beforehand, if I'm not too sure of what type of pointer I should go for, I'll simply declare it as wide star. Now if you recall, the dynamic memory allocation or deallocation functions, they return a pointer of type wide star. Let me give an example. If you look at malloc function, we know that it is meant for assigning a certain number of bytes continuously in memory. Okay. Now, if you want to go for, let's say, n number of integer type of memory, or float memory, or character memory, you just have to declare it. But in advance, if you're not too sure of what type of memory to go for, then you can always say that you want to go for a wide star pointer, with the help of which you can collect the return type of malloc function. That is even true in the case of calloc function or memory deallocation related functions. So if you use a wide star or wide pointer, then there is not much headache. But only thing is, you just have to make sure that you address the appropriate number of bytes. That's very important. However, there is one downside. The downside is that you don't want to dereference a wide pointer. That means wide pointers cannot be dereferenced. Well, they can be dereferenced provided they are appropriately typecast. Otherwise, the compiler wouldn't know how many number of bytes are to be read for the purpose of interpreting a data. Now, there are a couple of things we should be quite careful of. First of all, let's look at a special constant pointer called null. It actually means that it points to no valid data. I think we have experienced this when we were talking of the data structures course in the college. So when you actually declare a pointer, now if the pointer should not be pointing to any invalid memory location, it's always a good programming practice to make it point to null. Okay, and if you make it point to null, any pointer is pointing to null, then you should not be dereferencing it, because if you dereference it, it will cause a segmentation error or segmentation fault. Its definition can be found in these header files, stdlib.h or stdio.h. This is one type of special pointer. As I told you, the second type is wide star. It's a pointer which can point to anything, or it's called generic pointer. Now, we just have to be a little bit more careful about different terms that are used in the context of pointers. The first term is wide pointer. I think right now we already know it. Wide pointer is nothing but a pointer which can be made to point to any type of data. So if I declare a wide pointer like wide star j, and using appropriate typecasting, I can make sure that j points to an integer in memory, or float data in memory, or character in memory, or long data in memory, so on and so forth. Now, what is the meaning of uninitialized pointer? Answers in the chat box. What is the meaning of uninitialized pointer? What is your interpretation of this? Any answers we have? Please interact so that we can actually learn so many things new. Okay, Shweta says it is not initialized to any variable at all. Well, that's perfectly right. For example, I simply say int star j. That's it. Yes. Rishita says when only declaration is done and if it doesn't point to any value, it's called uninitialized pointer. Well, Anusha says it's null pointer. Please note, an uninitialized pointer is not the same as null pointer. An uninitialized pointer is not the same as null pointer. This is very, very important. An uninitialized pointer, yes, Sangama also says it, declared but not assigned value to it. An uninitialized pointer just means that I have declared it, but I did not initialize it. As simple as this. Int star j. That is an example of uninitialized pointer. Now, if I say int star j is equal to null, int star j is equal to null, that means that j is now pointing to null. It is initialized now. Okay, so please don't confuse uninitialized pointer and a null pointer. The next thing is, let's say, dangling a pointer. Okay, any idea on a dangling pointer? Any idea? Answers in the chat box. Okay, is a dangling pointer same as an uninitialized pointer? Dangling pointer, is it same as uninitialized pointer? Yes or no? Dangling pointer being same as uninitialized pointer. Rajat says yes. Do we have different answers? Utpala says it's not. Aishwarya also says it's not. Then what is the difference? What is the meaning of dangling pointer? Oh, very nice. Anusha says it. The point is, um, if I have declared a pointer, yes, if I have declared a pointer, for example, let's say int star j, and if I have made it to point to some memory location, it's called an initialized pointer, right? Now, due to some circumstances in programming, if that memory location which is pointed to by a particular pointer, if it is not available, then the pointer is called a dangling pointer. The classic case is this. I declare a pointer and I make use of it for a dynamic memory allocation, and I initialize it with the set of newly available addresses in memory, right? Now, after my job is done, what I do is I simply say free, right? Or I make use of delete operator in C++. When I say free or delete, now those locations are no more available in memory. They are not valid locations. But in that case, a pointer which was pointing to those locations earlier now is going to be called a dangling pointer. Okay, so a dangling pointer is a pointer which was pointing to some valid memory location earlier, but now if it points to not a valid location, or if the location is not available, then it's called a dangling pointer. Okay, so uninitialized pointer is very different when compared to dangling pointer. Of course, in one sense you can say a dangling pointer is an uninitialized pointer, but at some point in time a dangling pointer must have been initialized with the address of some variables or some arrays or some strings in memory. Now, we should also be careful about one more type of pointer called wild pointer. Any guess as to what this could be? Wild pointer? Answers in the chat box. What could be a wild pointer? Any guess? Okay, so wild pointer is an uninitialized pointer. That's what Rachita says. Do we have different answers? In one sense, maybe yes, but more appropriately, a wild pointer is another name for a dangling pointer. Okay, wild pointer is another name for dangling pointer. So both of them are technically the same. So I want to repeat this once again. A dangling pointer or wild pointer is a pointer which was pointing to some valid memory location earlier, but now it is not available. The memory location is not available. Now, if this is the case, such a pointer is called a dangling pointer or wild pointer. The case of uninitialized pointer is different because you just declare the pointer and you don't initialize it. That's called an uninitialized pointer. So that's pretty much about pointer arithmetic we had to cover. Now let's start looking at pointers and arrays. Now this is going to be one more interesting and important session because many questions can be asked on pointers and arrays, and we just have to be a little careful about it. Let me just go through some basics of arrays. It's well known that arrays, they actually comprise of the collection of similar type of data together. So I can have an array of integers or floats or characters or any other type. Then the array elements are indicated like this. So this statement is an example of integer array X, and the elements are statically initialized like this. Well, it is not necessary for you to initialize them like this. You can always make your programs more interactive by asking the user to enter the data for you. That is quite possible. And we also know that the array index starts at 0 and then it proceeds to 1 to n. And if you want to access any element of the array, you just have to make use of an index value. Depending on the program requirement, you may select to access these numbers in a sequential way or in any way you can access them. It's very important for you to know that these numbers or elements are stored in consecutive locations in memory. This is very important. They are stored in continuous set of locations in memory. So this is very crucial. Well, there can be a couple of questions. For example, as in this case, let's say, if I have declared an array of 5 integers, so the content at x of 0 is 1, correct? X of 1 is 2, x of 2 is 3, x of 3 is 4, and x of 4 is 5. Now this is very simple to understand it. Now what happens if I say x of 7, for example? Is it okay to do like that? Answers? Is it okay if I say x of 7 if my array is just like this? Please note we are building the base for understanding pointers and arrays. But before that, let's try to understand some important aspects of arrays and then go to arrays and pointers. So is it okay if I say x of 7 in this case? Can I access that element? Shraddha says yes. So do we have a different answer? Is it okay if I say x of 7? Yes or no? Yes, Anusha says yes. Please note your answer is completely right. You can say x of 7. That means you can index beyond the limits of this particular array. But please note that it is completely not correct in terms of semantics. But unfortunately in C language, there is no any error checking that actually happens here if you go beyond the bounds of or the range of the number of elements present in an array. Well, C++ has tackled this particular problem. You would know that C++ has some kind of a feature for exception handling and standard template library as well. So with the help of which, if you go beyond the bounds of an array, what happens is you are simply flagged with some kind of error message saying that this is not a valid data. Okay, so this is a very important aspect. So obviously you can either address the contents of an array using the square bracket notation by indexing them, or you can make use of pointers for manipulation of data. Now, let me just look at an example. If I have declared an array of, let's say, four data members, ampersand array of 0 is equivalent to ARR. What is ARR? ARR is the name of array. So when I say ampersand, it means the address of array. Address of which element? Address of 0th element. So as to say, this particular statement indicates the starting address of the array, isn't it? So it is very important for you to understand that if I just take the name of the array, this by default returns the starting address of the array itself. Now, if you look at A of I indexing, now this is equivalent to star A plus I. Star A plus I. How do I read this? Content of A plus I. What is the meaning of A? A or ARR as the case may be. So A or ARR indicates the name of the array. So I know that the name of the array gets me the address of 0th element. So as to say, this corresponds to the base address or starting address plus I. I stands for the index variable here. So I is going to range from, let's say, 0, 1, 2, 3, so on and so forth. So I'm actually talking of the base value plus some index value here. Its content, that's the meaning here. So A of I is going to be represented as star of A plus I. So this is a very crucial thing you must be able to understand. Now, let's try to work a little bit on the software tool. As mentioned, we are looking at the dev C++ compiler. Okay, now here I have a simple example for indicating how we can actually make use of arrays. So in this case, I'm trying to have the declaration of array, and the message enter three numbers is displayed here. So I'm just going to read some three numbers here. So just observe the way in which I'm trying to indicate the contents of accessing array. So instead of saying ARR of I would say ARR plus I, because I know that both of them are the same. Now after that, I'm going to just print the content that is entered by the user. So if you just look at the way in which this gets run, it says enter three numbers. So I say numbers are 11 and then 22 and let's say 33. So as simple as this. So this means that you can either make use of ARR of I notation or ARR plus I notation. Now in this case, I did not put star here because understandably, I'm trying to read the contents using a scanf statement. Now, if you were to actually display the contents, you can also do something like this. I'm going to say star of ARR plus I. So let's try to compile it and then run it. So it says enter three numbers. Let's say some three numbers are entered here. So it's perfectly okay to make use of star ARR plus I, because this is exactly same as writing array of I. So this is a very important aspect you must be able to understand all the time. Now, let's try to go through a simple example of finding the output of a particular example. Now, in this case, I'm just trying to read some numbers, 6 in this case. I'm trying to ask the user to enter them, and I'm displaying them. Nothing special about this example. What is going to be the output if I look at this code? Okay, so what is the difference between the previous code and this code? Just only one statement difference. Now, if you observe very carefully, the content that I have indicated in red color here was like this earlier in the previous slide. Instead of saying ARR of I, I'm saying I of ARR. Now the question is, what is going to be the output? Answers in the chat box quickly. Instead of saying ARR of I, I'm trying to say I of ARR. So what is going to be the output of this program? Quickly. Okay. Any answers? Please note that it is going to be the same. It is going to be the same. Well, let me just very quickly look at the you know answer. Instead of saying ARR of I, I'm going to say I of ARR. So if you just try to compile it and then run it, you still get the same output. So this is happening. This is happening because of one very important thing here. Okay, I think we have a question here. So is missing ampersand in the scanf statement here correct, sir? Okay. Yes, we are missing ampersand here because as I told you, if I just name the array, it gets me the starting address of the array. So either you can put ampersand sign or you need not put ampersand sign shake. Okay. So if you interchange both of them, it still gets you the same answer. It is because of the fact that the moment I write ARR of I, it is same as star of ARR plus I. Now this is what we have seen, right? Now, if star ARR plus I is given to us, can we not write it as star I plus ARR? Because we know that addition is commutative, right? So if this is so, it's quite possible for me to write its equivalent as I of ARR. So hence this logic works. So don't be under the wrong impression saying that an array must be always indexed using an index variable. If you swap them, their locations, it's quite possible for you to still access the contents. And that's a very, very important aspect you must understand. Let us look at one example of finding the sum of, let's say, n numbers. I'm just going to go here and then show you the output of the program. Now, I have copied this example here, and this is how it looks like. So some array is declared here to have max of 6 numbers or elements. Some variable is declared as integer and it is initialized to 0. And I'm just trying to read the contents of 3 integers and scan them by using ARR plus I kind of notation. And when I want to find the sum, I'm going to say sum is equal to sum plus star ARR plus I. At the end of this for loop, I'm going to display the sum. So let us see how it actually behaves. So it says enter some 3 numbers, and if I just enter them, it says sum is equal to 66. As simple as this. So this also tells you a very, very important concept. That is, if you want to access the contents of an array, it can be integer array or float array or any other type of array. And if you want to do any kind of arithmetic operation or manipulation, it is quite possible for you to do it. Now, moving on, let us try to have an example of connecting a pointer to an array. Now, this example, I'm just trying to show it to you through the demonstration once again. So here we have the same code being pasted. I have declared an array of, let's say, integers. In fact, you can do so, or maybe you can give a chance to the user to enter the data. Just to save some time, I'm going to statically initialize the array like this. So the contents are from 1 through 5. Now I declare p as a pointer of type integer, and I'm just saying int star p is equal to a. So this is exactly the same as writing int star p is equal to ampersand a of 0. Because ampersand a of 0 is going to get me the starting address of the array. Now, using a simple for loop, we are going to iterate from I is equal to 0 to 5, because that's the total number of elements we have, and then printf %d star p. So star p gets me the content of p. Now, since p is pointing to the starting address, in the first iteration, I'm going to display 1 as output. Now what I do is I say p++. So when I say p++, it starts pointing to the next integer in the array, as I showed you in the previous slide. So star p would be now 2. So that gets printed in the next iteration. And then once again we say p plus plus. In the next iteration we'll have the content of 3 getting displayed on the screen, so on and so forth. So let me very quickly run this program to you and then show you the output. Okay, there are missing spaces here, so that's why it's getting displayed as 1 through 5. So this is as simple as this. Now I just have a very simple question to ask you to check if you got the concept or not. Now, um, is it a good programming practice to say something like p is initialized to a, correct, and then I manipulate p itself? That means I'm trying to say continuously p plus plus. So is it okay to do like this? Yes or no? Is it okay to say p plus plus like this? Rachita says no. What could be a possible reason if the answer is no? Or if the answer is yes, what could be a possible reason? Any answers we have? Okay. Um, well, syntactically, there is no problem. I know this. Why? Because the program has now run. But please note, semantically speaking, now if you say p plus plus, is it not that I'm trying to point to successive locations in memory? That means the content of p is now going to be changed every single time I iterate through the loop. Yes. The answer is, since at the end of this loop p points to the last location, now for any further manipulation, I need to reinitialize it. That's very important. Okay, one of the answers is maybe no, because we missed the first location. The answer is yes, if you want to hold back the initial location somewhere. Yes, the answer is perfectly right. So please note, syntactically it is perfectly okay to do like this, but semantically speaking, now if you say p plus plus, now p has moved to point to the last location in memory. So uh, we should not be proceeding further saying that okay, p is still pointing to the first address in memory. So usually in data structures, we do like this. In linked list programming, you must have observed. Now we always make use of a temp pointer to point to the first node in the list, and then we manipulate it. So even if the content pointed to by temp pointer is different, we still don't lose track of the starting address of the linked list. So that is a very, very important thing we must understand. Now, let me very quickly show you the concept of the way in which pointers will be connected to arrays. Pointers will be connected to arrays. Now, in this code, actually declares an integer pointer p. Now look at this. On line number 6 on your screen, we say int opening bracket star ptr closing bracket then square bracket 5. Now what does this mean? Okay, this is very important for us to understand. Now we use the usual trick of reading from right hand side to left hand side. So we look at the square bracket here. It means that this must be some sort of array index. There must be an array. So it says 5. So I'm just now going to say that it's an array of 5 elements, let's say. And then after I encounter this opening square bracket, I anticipate the name of the array to be present here. But unfortunately, there is no name of any array, but there is this round bracket or parenthesis, ending parenthesis. So when I get this ending parenthesis, it must have an opening parenthesis correspondingly. So whatever that appears in these parentheses must be read in a single go at a stretch. So now inside of these braces or brackets, there is star ptr written here. Star ptr. So now, how do I understand this? So please note, whenever the round brackets are put, it means that this is one entity. Now this entity is not just a name, but it is star ptr. It means that it is a pointer. So now this means that it's a pointer to an array of 5 integers. To an array of 5 integers. Now, Please be very careful because this is a very fine aspect you must understand. I'm talking of a pointer to an array of 5 integers. It is not just a pointer pointing to some data. It is pointing to an array of 5 integers. Next, where is the array? It's right here. Int arr of 5 is what we do. And then say it's time for us to initialize. So p pointer, I'm going to initialize to the starting address of array. So I can say either p is equal to arr or p is equal to ampersand arr of 0. Correct? I can make use of any of the methods. And then say ptr is equal to ampersand arr or ampersand AR of 0. That's quite possible for us to say this. Now the whole point is I make use of pointer p and a pointer to an array of 5 integers which is ptr, and I'm just trying to show you how both of them are different. I repeat, p is just a pointer to an integer, but this is a pointer to an array of 5 integers. So I'm just going to initialize them and I print the addresses pointed to by p and ptr here. Okay, and then I say p plus plus and ptr plus plus, and we're trying to print the addresses once again after this manipulation is done. So now please tell me what is going to be the output expected. Any answers in the chat box? Let me assume that the starting address of this array arr of 5 is, let us say, 1001. Or let's say 1000 for the sake of simplicity. Let's assume that the starting address is 1000. So what will be the value of p and ptr here due to first printf statement, and what will the value of p and ptr due to second printf statement? Any answers? We assume that the starting address of the array is 1000. Okay, due to first printf statement, what will be the output of p and ptr? P and ptr due to first printf statement. That's correct. P and ptr, both of them are pointing to same location, so they must be pointing to 1000 address. Okay. Now, when I say printf after I say p plus plus and ptr plus plus, the content that is displayed on the screen would be very nice. Some of them are given the correct answer. So please note, due to second printf statement, p gets incremented by just 4 bytes if the size of integer is 4. But ptr is now not incremented by just 4 bytes. It is incremented by 20 bytes. I'm talking of 32-bit machine now. Why 20 bytes? Because there is an array of 5 integers and the size of one integer is 4 bytes. So 5 times 4 is going to be 20. So it's very important for you to realize that the addresses are as shown here. Now on this machine, look at this. Initially, P and PTR, both of them are pointing to same address, let's say 3280 here. And if I increment it, P is pointing to 3284. That's quite understandable. But PTR is now pointing to 3300. So 3280 is now getting changed to 3300. That's a jump of 20 bytes. So this means that PTR is not just a pointer to an integer. It is a pointer to an array of 5 integers. Array of 5 integers. So this is a very, very important difference you must be able to understand. Okay. Let's try to go further and then let us understand a few more aspects. Let's come back to this example. I've been able to access the contents of array A using pointer P. Now the question is, what happens if I say A++? Answers in the chat box. Answers in the chat box, please. What happens if I say a plus plus? Any answers we have? Okay, Monroe says it. He says the address of array is incremented. Let's wait for a different answer. Okay, Shweta says that it's going to point to the next location, a of I plus 1. Very nice. Do you have any other answer? Sangama says it's a of phi. Why a of phi? Because the array size is, starting from 0 to 4. Okay, let me just try to show the output to you, and then let's try to reason it out. Okay, now instead of making use of pointer p here, I'm just going to say something like this. Shall we say a plus I, content of it? So I can always say like this, right? Star a plus I, right? And then instead of making use of p, I'm going to say a plus plus. Okay, Aishwarya says the size is incremented. So I'm just going to run this program, and then look at this. There is a problem. The problem is that we have an error. It says L value required as increment operand. L value required as increment operand. Well, if you look at this piece of code, this looks perfectly okay, but please note that it is not okay. The problem is with this particular statement. Now, just a few minutes ago, we said A gets me the starting address of array, right? So by that argument, I would say A++ should work. And then since I'm trying to print the contents of this array using the notation star A plus I, this particular loop should perfectly run fine. That's the argument. But that is not the case. It is not the case because when I say A++, please tell me what is the meaning of I++? What is the meaning of I++? I'm just going to make use of this as some space for illustrating to you. When I say I++, is it not same as writing I is equal to I plus 1? Is it not? So that means I take the value of I increment it by 1, and then assign the incremented value back to I, right? Now the point is this. If I have A++, it means A is equal to A plus 1, isn't it? But what is the meaning of A? A means the starting address of array. I change the starting address of array by 1, that's perfectly okay. But when A plus 1 content is getting back into A, I have a problem. Why? Because starting address of an array, you simply cannot change it. Because the OS would have selected certain set of locations which are free in memory. I think you must have gone through a course on OS now by this time. And then in that course, you must have studied the concept of virtual memory and memory management. What really happens is when you have a certain set of locations in memory which are free, the OS is going to look out for sufficiently large amount of memory for the purpose of allocating some space for this int a of phi, right? Now, if the space is sufficient, then those locations are allocated. Otherwise, defragmentation is going to happen, and so on and so forth. Compaction will be taking place, so on and so forth. So the moment I say a is equal to a plus 1, it just means that I'm trying to increment the value of a by 1. Now, this is perfectly okay. This part is perfectly okay, a plus 1. But I may not be able to assign it to a because that is going to change the very base address of a. And hence, I simply can't say a++. That means you cannot simply change the starting address of any particular array as such. And hence, a++ is going to get me an error message. So this simply won't work. Okay. So you don't expect it to point to the next location or point to a of phi, so on and so forth. This is a very important takeaway. The same thing is true with respect to pointer to multi-dimensional array. Now, this kind of notation you must have seen for the purpose of implementing 2D arrays or matrices. So if I say a of I and j, this gets internally converted as content of a plus I. Now, this is something we already know. And when I say a of I followed by j, this content is going to be added with j, and I try to look at the value stored at that location. So we have star of a plus I plus j. So this is going to be the equivalent value corresponding to a of I j. Well, the argument still remains the same. I mean, the same kind of n dimensional arrays can be had with the help of this kind of notation. This example we already have seen in the case of pointers to an array. Okay, so this is one more important slide where you can see the equivalence between different code fragments. Now, in the first case, I have an integer and an array of 10 numbers. So using a simple for loop, I'm just going to do some kind of operations. On the other hand, I have an integer pointer and an integer being declared. Using a simple for loop, I still make use of p, which is a integer pointer, initialize it to array, and then go up till certain number of locations in memory and manipulate the contents. So both these code blocks are functionally equivalent. So this is a very, very important thing you must understand. The last part of arrays and pointers, it's quite possible for us to have an array of pointers. I repeat, array of pointers implies an array as shown here, which stores different addresses here. It doesn't store data, but it stores addresses. Now let me just look at an example. Character star city PTR of 4. Now in this case, I'm trying to store the names of different cities like Chennai, Kolkata, and so on and so forth. So city PTR is an array which consists of the starting addresses of different arrays themselves. In this case, it consists of different characters. So when I say 8,000, please note 8,000 is the starting address of this city PTR array. Now the first content is 1000. So starting from 1000, I'm going to have the ASCII value of C stored, and then in the next location, ASCII value of H, ASCII value of E, it just goes on. Now, in the next location, depending on the machine we have, this addresses will depend on the machine. So the next location will have the starting address of second string. Now in this case, it is 2000. So the ASCII value of K, ASCII value of O, ASCII value of L, they get stored here in consecutive locations. The same thing is true for the third string, Mumbai, and the fourth string, New Delhi. So this is quite possible. What we must understand or observe right now is that I have an array, I repeat, I have an array which doesn't consist of data. It consists of pointers. So an array of pointers is very much different when compared to a pointer to an array. I repeat, an array of pointers is very different when compared to a pointer to an array. Well, let me just try to see how to work with this particular example, and then let's go for it. Okay. Okay, well, I'm just going to take this example a little later on when we discuss about strings. So in that case, I'm going to tell you. But the most important thing here is that I have an array whose contents are the addresses, not the data. And that's called an array of pointers. Also, please look at the syntax here. How do I understand it? Very simple. I start from the right-hand side. I encounter the brackets here. So when I say I have brackets, it must be some kind of array. That's what I understand. And then I expect an array name here. Well, the array name is citptr, but it's not just a normal array. It is an array of type char star. So I am going to read citptr as an array of character pointers. That means the contents of this array are all the addresses, not the data. Now just try to compare this with previously what we have shown. That means I have a pointer to an array of integers. That's very different. There I have only one pointer which can point to different locations in an integer array or float array for that matter. So both of these are very, very different concepts. Now, let us consider a simple example. The same example is shown here, with the help of which I'll be able to get the output. So we have the same example here. I have typed in here, and then let's try to execute it. So the output will be as expected. The city names will be displayed here. Just look at the way in which the logic is built. So we say char star city ptr of 4, and once again these city names are statically initialized. In fact, you can also make sure that you declare an array and then make a pointer point to it. All these kind of manipulations are possible, and integer variables are declared. So different cities are going to be accessed using the array index or loop index r. So we have the value of c as 0. So every single time until we encounter null character, we are going to display the contents of city_ptr of r. City_ptr of r. Now the inner while loop is going to do this job, and the value of c is incremented every single time, because c is going to act like an index inside of this particular for loop for the purpose of displaying out the contents of one single city. Once this is done, the value of r is incremented. The value of r is incremented. So that's going to get me to the next city. For example, in this case, Kolkata, so on and so forth. So this is how we get the output. Okay. Now, one or two important declarations I'm just going to take you through, and we'll have a quick break of 5 minutes. So please understand, in interviews, questions can be asked depending on how these declarations appear. So maybe the declaration is given to you and you're supposed to understand it or describe it, or if the description is given to you, you must be able to write its syntax. So if I say int a, it is very simple. A is an integer variable, correct? Now if I say float b of 5, I make use of the same trick. How do I do this? I start from the right hand side, and then there are square brackets. It means that there must be an array. So I expect the array name to be here. So it's b now, and this array contains all float values. So now I'm very clear. So b is a one-dimensional array of size 5 floats. Next, int star c. C is a pointer of type integer, or c is pointing to an integer. Both mean same. Next, character d63. So how do I understand this? This is pretty simple. D is a two-dimensional array of characters. D is a two-dimensional array of characters. So I can have 6 different strings here, for example, if I'm talking of an array of characters, each of max size equal to 3. This is very, very crucial. Well, it's very important for you to realize that memory is not two-dimensional in nature. Memory is still linear. It consists of a sequence of locations in memory. For example, location 0, location 1, location 2, so on and so forth until the last location, location n-1. But the way in which we interpret data gives rise to two-dimensional representation of data, or 3D representation of data, or n-dimensional representation of data. But all of them are stored in sequential locations in memory. Next, float star star x. Now this is very simple. X is a pointer to a pointer of type float. I repeat, x is a pointer to a pointer of type float. In simple terms, x is a double pointer. Next, int star e of 5. Okay, this will be read as a one-dimensional array of size 5 of pointers to integers. Okay. Then int g, let's say we start from right hand side, we encounter round brackets or parentheses. They are not square. So now there is no question of array. This is not an array. This is an example of a function. So the left hand side here, I expect the function name to be present. So in this case, g is the name of function. So now I understand it. G is a function which takes some arguments and it returns an integer value. Next, float avg int star. Once again, we make use of the same technique. We move from right to left. So round brackets are present. So I'm talking of a function name here. So avg is a function name which takes int star as argument and returns a float value. Now let's understand this. Char star h of some arguments here. How to read this? H is a function which takes some arguments but it returns a pointer to character. I repeat, h is a function which accepts some input arguments and returns a pointer of type character as a return type. Now look at this. F is written along with star enclosed within parentheses. So it means that f is a pointer to a one-dimensional array of 5 integers. So this is not just one integer pointer. No, it is a pointer to an integer array. How many integers are there? There are 5 integers, and you should be very careful about it. Now, last one. Once again, I start from right hand side. There are parentheses here. There is nothing inside of it. So it must be some kind of a function name. So when I come here, there is no function name. Once again, something is written inside these brackets. So this must be read in a single go, at a single stretch. So now I say that fp is a pointer, but wait, there was supposed to be a function name here, right? But there is no function name. There is a pointer given. So now I say fp is a function pointer. Function pointer pointing to a function which actually takes no input arguments but returns integer as the output value. So I intentionally got this concept of function pointers here because you must be able to understand the distinction between a simple function, a function taking some pointer arguments, a function returning a pointer as output type, and then a pointer to an array of 5 integers and a function pointer. Just look at the small difference, subtle difference between each of these declarations. Okay. So last one is the concept of function pointer. We are going to have a discussion on function pointers on the last day of our program. Do we have any doubts? Any questions? Okay, so if that is the case, then I think I request Kotesh sir to come in and then conduct the poll questions. Um, so in that time, we'll have a 5 minutes break and then we'll continue with the second part of today's discussion on pointers and strings. What do you, Kotesh?
Thank you, sir. It was a nice session on pointers and arrays. So students have enjoyed the your session especially. It was quite more interesting as well as interactive session, sir. Students, in the chat box, I have given you the uh, poll questions. Okay, I displayed the uh, ID, so portal ID. So you can get into that portal ID and you can take the quiz for 5 minutes. I just enable the link. Okay, I have started accepting the responses. I hope all of you can see the questions. The timing given will be 3 minutes. There are 4 questions, 3 minutes. Soon after 3 minutes, I will be disabling the link. Okay, I got till now. I got 7 responses. So wait. Okay, I'll just hide this now. Anyways, many of you have started taking the quiz. Okay, so 28 responses. So once again, we repeat that your final certification of this particular program will depends on the responses based on the poll questions, all the poll questions, feedback, and followed by final quiz. I repeat once again, all the poll questions, feedback, and the final quiz. Okay. The certificate will be issued based on your responses for these three conditions. Okay. Make it fast, guys. Another 2 minutes. Okay, last minute to go. Okay. Sir, shall I stop
Yeah, please go
the
ahead.
accepting the responses now? Okay, okay. Thank you, sir. There are total responses 37 responses till now. I'll wait for another 2 3 seconds, guys. Finish off your quiz. Click on the submit button. 5, 4, 3, 2, 1. Now I'm stopping accepting the responses. Thank you. And now you can see the average answer, the missed questions and the other part of the results here over the see the first question. An integer pointer can be increment by 2. The answer is true. Around 39 students on total given the responses, out of which 29 are correct. That is around 74.4% students have given it as a correct answer. Now, the second question is which among the following is true? We can subtract 2 pointers. We can multiply a pointer by a scalar. None of the above. Around 32 students, that is 82.1% of students says that we can subtract the 2 pointers. That is right answer is given by 82% of the students. Which of the following is correct? Size of an integer pointer is twice the size of the float pointer. Size of the float pointer is twice the size of the integer pointer. All pointers have same size. So third option is the correct answer. Around 76.9% of students have given this answer. Why memory gets allocated for dynamic memory allocation, reallocation based function? Which memory gets allocated for dynamic memory allocation, deallocation based function? That is data stack, data heap, and code memory. The correct answer is data heap. Around 19 students. It's very less students have given this answer, 48%. Rest of the questions we got a very good responses. And thank you for taking this poll question 3. Now once again, we'll quickly start with the next session of this day. Now the second session is on pointers and structures. So once again, I request Naulgun sir to
Strings.
start with the next session, that's pointers and structures.
Okay, thank you, Kotesh sir. Yeah, well, there's a small change. It is pointers and strings. Pointers and strings. Pointers and structures. We're going to deal with the last on the last day of our session, last day of our course. So right now we have pointers and strings for session 2 of this day. Well, I think even this kind of questions are quite likely, and you need to be quite careful about how you know you understand them and interpret them. So when I say a string, it is nothing but an array of characters. Well, hold on for a minute. Just an array of characters is not a string. It must be terminated by a null character. It must be having a null character at the end. Now, if there is no null character, it means that I just have a sequence of characters. That's all. That is not a string. Now, this is very important because if I look at a string like hello, HELLO, now there are 5 characters here. Now, there is going to be an implicit null character here. If there is no null character, then whatever characters that are stored in the memory, they simply just will be considered as a part of this array of characters, which is not completely correct. So it must be terminated by a null character. Null character is indicated as \0 value, and arrays for bounded length strings. I mean, this is also one important concept. The moment we have a null character, it delimits the number of characters or the length of the string that we want to actually have here. Now there are also pointer to for constant strings of unknown length. Now just look at a simple example here. If I say character str1 of 15, it means that statically I'm trying to declare the max length of this array as 15 bytes or 15 characters. So when I initialize them like this statically with the characters like hello world, they get actually stored in here in the successive locations in memory. That's how it is done. When I say character star str2, this is an example of initializing a pointer to character string to the string hello world. That's very important. Now, if you look at the contents of how this hello world will be stored in str1, it will be the ASCII value of h in, let's say, the first location in memory, and then we have the ASCII value of e in the next location, and then the third location, it just goes on. So what is the size of memory required for storing one character? What do you say? Answer. What is the size of one character that must be stored in memory? How many bytes? It is? Quickly? It is. It is definitely 1 byte, right? Definitely 1 byte. So the first address, let's say if it is 1000, the location 1000 will have the ASCII value of h, 1001 will have the ASCII value of e, so on and so forth. So please note \0, yes, that's correct, Sangama. \0 is the null character which will terminate the string. There is a very important thing you must know in C language. There is no any implicit string type of data available. No. That means it is just treated as an array of characters. So whatever kind of manipulation you want to do, you just have to set up some kind of loop, like for loop or while loop or whatever, do while loop, and then you should be able to manipulate individual characters, and that's very important. Okay? So the strings are just implemented as an array of characters, char str of 10. In this case, str is an array of 10 characters. If I say char star str points to the beginning of a string of some length, unspecified length. That's very important. So it's quite possible for you to make use of the variable name as string string in C language comfortably, but be very careful in C++ because string type of data is available over there. In fact, string.h header file is available, so it's a good programming practice not to have any conflict with the libraries names or library functions names and so on and so forth. So let us very quickly look at some important library functions which can be of some use to us. The main header file is string.h. So strcpy is one of the important library functions which stands for string copy. So if I say s1 followed by s2, the contents of s2 will be copied into s1. Now that also includes the null character from s2. So this is going to change s1. S2 remains unchanged, but S1 will be changed because S1 is the destination here. Then we have strncpy. So the format is string 1, S1, then followed by string 2, and then the value of n. So obviously, it means the first n number of characters will be copied from string 2 to string 1. So it is same as strcpy, but only to an extent of n characters are getting copied here. strcmp is one more important string related functionality which compares two strings s1 and s2. So it returns a negative integer if string 1 is less than s2. It returns 0 if both the strings are equal. It returns a positive value if s1 is greater than s2. Its variant is in terms of strncmp, string n compare. So it's going to work like string compare itself, but only n characters will be compared at any given point in time. So please be very careful about some important string related functions. The library is quite huge. So we also have strcat, string cat or string concatenation, which is going to concatenate string s2 into string s1. Once again, string s2 remains unchanged. String s1 will be changed because s1 is a destination. Its variation is strncat, or only n number of bytes or contents from string 2 will be concatenated with the contents of string s1. A very popular and very handy function strlen, which stands for string length, which returns the total number of characters or the total length of the string itself. strchr, it returns a pointer to the first occurrence of character ch in a given string. For example, if the string is hello, hello, and if the character I want to search for is, let's say, h, it returns the pointer to the first occurrence, that is 0th index. Now if I say the character I want to search for is l, so we have the character string like hello. So l is going to appear after the character e at index number 2. So a pointer is returned to the first occurrence in the given string s1. So strchr, it is same as strchr, but it actually tries to look at the contents starting from the last byte. So it is same as the above function, but the pointer points to the last occurrence of the character ch. One more handy function is str. So it tries to look at a substring and returns a pointer to the beginning of that substring if the substring is found. Otherwise, null is going to be returned. So very quickly, let me go through the C++, Dev C++ compiler for the purpose of showing some very important basic things over here. So first of all, let me just look at, okay, the way in which I'm going to read strings. I'm just going to display it and then see. It's a very simple example, nothing great about this. I declare an array of characters. and integer variable is declared here, and then we actually have some kind of prompting to accept the name. And just look at the way in which we are trying to accept the strings. For example, percentage yes followed by ampersand arr. Okay, you could as well say just arr, because I know that arr just gives me the starting address of the string itself or the array itself. So after that, I just want to print the contents on the screen. So if you try to compile it and then run it, it says enter a name. Let me say if I just give ABCD as some input, I just hit enter and the output is obtained as ABCD. Very simple and straightforward. Now, once again, let me just run it again and then see if it makes some sense or not. So it says enter a name. Then we have, okay, X, Y, or let's say the very famous sentence hello world is actually input, but the output is not hello world, but it is just hello. The reason is that the moment I have hello space world, the scanf function is going to take space as a delimiter. So the moment I say percentage yes, this is going to just get me the first word, which is hello. The word string is missing now. So what can be a possible solution for this kind of string manipulation? So answers in the chat box quickly. So how do I get around this problem? So scanf is taking a blank space as a string delimiter or string terminator. So how do I get rid of this problem? Any answers we have? Oh, you say percentage C. Okay. Shweta says percentage C. That can be a possible solution. But I just have to manipulate character by character, right? The answer is correct. But I just have to set up some kind of looping structure until I read a null character. So that's a possible way. Otherwise, just look at this. Instead of scanf, I can make use of get yes statement. Let's try to see if it works or not. Okay. We have an error message getting popped up. Okay, so I just said ampersand arr. Well, you can just say like this arr. Now, oh, the syntax is wrong here. So I just have to make the mention of arr itself. So I'm just going to click it, and then it says enter name. Then if I press a hello world, like what we have done earlier, now it says you entered hello world. So this function getYes is not going to have space as the delimiter. It's going to look at the terminating character, which is a null character in this case. Please note, while I get the output here, now getYes is slightly discouraged. It is treated as a little dangerous function to use because of one particular reason. And do you know what reason has caused getYes to be a dangerous function? Why should not I use getYes function? Any answers in the chat box? We don't want to make use of scanf because scanf function is not going to work according to my requirement. So I go for getYes, but getYes is said to be a little dangerous function. What is the possible reason which you can think of? Any answer? Please try to come up with the answers. If the answers are right, very good. Otherwise, we have some scope to learn, right? So please try to answer these questions. Okay, getYes is basically treated as a dangerous function because of the buffer overflow problem. I repeat, the buffer overflow problem. What happens is, given the size of buffer like this, now please check what's going to happen if the length of the string is too huge. The first 20 characters what I have reserved for storing some content, but if you just overflow, should those characters be treated as a valid string or not? That's the big problem. So if there is any case of buffer flow, then getS cannot handle it. So that is why getS should hardly be used. So what is the solution? The solution is to make use of a more secure and safe function called fgetYes. fgetYes. So if you use it, it's also going to work fine. For example, we have a percentage yes, and then we have ARR, the name of the array, and then we have, let's say, um, the source of input. In this case, it is standard input, right? So I'm just want to click on this and have, okay, there's a warning here and an invalid conversion from char star to int. So I'm just going to okay. Oh, I guess we have syntax problem here. Okay. Okay, the syntax is slightly different. I just made a small mistake here. Let's assume that the length is going to be 20 here, and then we have the first one is char star yes. So I'm just going to have um, ARR here. Okay, there's still an error. Cannot convert from. Okay, I just made a mistake. So when I run this, it says enter name, and then we have hello world. Uh, let's say good, and then these characters are being displayed. As simple as this. Okay, so fgetS can be a more secure function which takes care of any buffer overflow problem, because syntax is, first of all, I mention the string name and then the limit on how many characters I want to read, and then we have the source of input. In this case, it is standard in. So this is how I make use of character arrays for reading and writing operations. That's very important. Okay, now moving on, let us try to understand a few more important aspects of uh, you know these things. The first thing is regarding how to find the length of a string. Now we have the library function called strlen, but it makes some sense for us to understand how this can be implemented. So the function is written here. The char str is passed as an argument, and then inside the function we have integer length equal to 0 as a variable to actually have the length of the string. Now just look at the way in which we have the while loop getting set up. So since we don't know the number of iterations we are going to have for finding the length of the string, I will not go for a for loop. So we go for a while loop. While str of len, initially the value of length is equal to 0. So str of 0 is going to get me the first character of the array. So if this is not equal to null, len is incremented every single time. So at the end of this while loop, let's say when I encounter a null character, we exit the loop and then return the number of characters present here as the length of the string. Now this is provided by the string.h library. Now this is the logic for finding the length of the string. Well, there can be different ways and implementations used for finding the length of the string. One such thing I just want to display to you. This is a very simple example using a for loop for the purpose of finding the length of the string. Now character str1 is initialized as hello world, just for the sake of saving some time, and then I set up a for loop. Now please be very careful. We say for I is equal to 0 to str1 of I. What does this mean now? It means initially the value of I is 0, So str1 of 0 gets me the first character of the string. Now, if this is not equal to, you know, null character, then we just keep on doing the body of for loop. Well, what is the body of for loop here? Please observe very carefully. At the end of the line, I have not given any parenthesis here. So this for loop is a for loop with a null body. There is no body at all. So what I'm trying to do here is I'm trying to increment the value of I, and I'm going to check if str1 of I is not equal to null. If it is not equal to null, it means that there is still string. There are still characters available. The moment I encounter null character, I simply stop because this is the terminating condition. At the end of this for loop, I'm just going to print the value of the length of the string. So I just have to change this message like the length is equal to %d, and that's how I look at the output. So if you run this program and see the output, it says the length is equal to 13. Obviously, if you count the number of characters here, there is a comma here, which is also a character. Then there is a blank space here, that's also a character. Then there is an exclamation mark, that is also a part of string character. Please note, the null character, the invisible null character, is not treated as a part of string for finding the length of the string. So this is how you can actually understand the way in which you read the strings and display the strings. Now, moving further, if you want to find the length of the string, as I just shown you, there are different ways of doing it. Using no pointers, what I can do is I can just set up a for loop and then increment the value of I every time, check the value of string of I, and the length must be incremented every time there is no null character encountered. So you terminate this for loop whenever you encounter null character. At the end of it, print the output. This is one way of doing it. Or else you can also try to do using the pointers. So now this gets us to the point of pointers and strings. Let's see how it's basically done. So the moment I say char star strptr is equal to hello, you know, starting from some address in memory, the ASCII value of h, e, llo, they are stored. And the moment I say char star strptr, this is actually a declaration part and initialization part as well. So strptr will be holding the starting address of the string, which is in this case 5000. Well, that is system dependent, but in this case it is 5000. Now I can do different set of operations on this particular string. For example, I can always make sure that I access h, e, llo individually, or I can just display these contents in reverse order, so on and so forth. This diagram also illustrates one more aspect where I make use of t, which is a character pointer once again, which is now made to point to the starting address of this particular string hello in the memory. So it means that multiple character pointers can be made to point to the starting address of a string. So let us quickly look at displaying the strings using pointers. Now, I just want to go to the dev C++ and then show you how this is done. The same program is copied here. So we have a character pointer star strptr, which is now pointing to a string hello. And then I also try to have one more pointer, char star t is equal to strptr. So this I'm going to use it as a temporary pointer for the reasons I just told you some time back. So while content of t is not equal to null, I just go on displaying it. And the value of t must be also incremented every single time I display the content. Otherwise, I simply get stuck in an infinite loop. So now I'm going to run this program and I am able to display the message hello. Okay, so please note here, the string was static as hello, and that is getting displayed now using pointers. Okay, now if you miss the manipulation of t++, that is going to result in an infinite loop. So please be very careful. Otherwise, we simply commit a mistake here. Now, it's also possible for you to find the length of a string using a simple function. It's quite obvious that you have to to have you know the prototyping of function like my string length here, my strlen, and I'm trying to pass a character pointer to the string. So just for saving time, I have str of 20 being initialized to string hello, and I just call the function and the address is being passed as str now. Inside the body of my string length function, what I have done is I'm just trying to have a simple while loop, and I increment the pointer str every single time I increment the value of an integer I and then display it. Well, let's try to see how this is going to work. Now, in this case, since the string is static, the count is displayed as 5. The string is hello here. Well, you can also accept the contents from the users and then try to find the length of the string. So you make use of either a function for finding the length of string, or you do it from within the main function. You do it using function pointers or without pointers, you still get the answer. Okay. Moving on, let's also try to look at an important difference. Okay, so can somebody tell me what is the difference between char e message of 15, character e message of 15, the string is invalid choice, and then char star err message, now this is equal to invalid choice. So what can be a possible difference between both of them in your understanding? Answers in the chat box. Yes, or both of them are the same? Any answers we have? Okay, are they same? Yes or no? Okay, you can just type in yes or no and then try to justify it at a little later stage. Are they same? Yes or no? No. Okay, if both of them are not same, then what can be a possible difference between both of them? What is the difference between both of them if both of them are not same? What is the difference? Okay, character is type. What does that mean, Sangama? Character is pointer. Okay, correct. The first one corresponds to a string, as Nikhil correctly put it. What about second one? Second one is a pointer to a string. Okay, first one is an array of characters. Second one is a pointer to a string. So, well, let's try to understand this with the help of an example a little later on. But you must be understanding that both of them are not exactly the same. Now, once again, let me just go back to the case of finding the length of the string using different aspects. Now, just to save time, I have written strlen here, and then let's try to look at the starting address of a string as star yes here. Now, different ways exist, as I told you. I just declare an integer variable n, and then I set up a simple for loop. Now, for loop is usually set up when we actually know the number of iterations in advance, but in this case, even if we don't know it, so I can still make use of it. So I start with the value of n is equal to 0. I check for the content of yes. Content of yes is star yes. If it is not equal to null, I just increment the value of n. So when I exit the for loop, whenever I encounter null character, the value of n would get me the length of the string, as simple as this. This is a pointer version of finding the string length. It's also possible for us to compare the strings. Now, this is the core part here, or core logic. So I'm assuming two strings, string 1 and string 2. So I should be able to compare both of them character by character. That's very important. Now, if any one of them gets terminated, then I should be able to quit. Otherwise, I just say if string 1 of I is not equal to string 2 of I. So if any one character does not match, then I'm trying to make use of a flag here. It's called a temp. So temp will be set. And when I come out of the for loop, if temp is reset, if the flag is reset, then I'm going to say both strings are same. Otherwise, both strings are not same. That's what we're going to say. Okay. So just look at the way in which strings and pointers and indexing can be actually used for performing different operations. Let's also look at string copy function. So obviously char star yes is the first string and character star t is the second string. Now I want to copy from t to yes. That's the meaning over here. So a simple while loop is set up. So what I'm going to do is I'm going to say while yes of I is equal to t of I. So what does this mean now? We are very careful in putting this particular operator here. This operator is assignment operator. So t of I, that means let's say initially I is equal to 0. So the first character is copied into the first character of yes. Now, if this copying happens, let's say the string is hello, H-E-L-L-O. So H is copied. Now that character H is not equal to null. So this condition is true. So I is incremented. And once again, I execute. I go to the t of 1 value, which is E, because I consider the string as hello, H-E-L-L-O. So the second character is E. So E is copied from T string to S string. Now E is not equal to null, so I increment I. Third time I copy L. Fourth time I copy one more L. Fifth time I copy O. Sixth time when I encounter T of phi, T of phi is null. So when I copy null character from T string into S string, so this condition fails. So I quit the loop. So this particular function copies string T into string S in a very simple manner shown here. This is a non-pointer version, I would say, because we made use of indexing of array or indexing into strings for the purpose of accessing different characters. Well, this can be further modified to make use of the pointer notation itself. So look at the previous slide. It used something like s of I, t of I. Now I'm going to use star s and star t. So the logic remains same, but the way in which I access is slightly different. I'm going to say while star s is equal to star t. Now this is not equal to null. So this is once again a carefully put assignment operator here. So star t implies content of t. So if I consider the same string like hello, H-E-L-L-O, so first of all, H gets copied into star S. So star S is H, which is not equal to null. So the condition is true. I enter inside, I increment S, I increment T also. So the next character is E. So E gets copied, which is not equal to null. The same logic continues, and then I'll be able to copy all the contents here from T string into S string. Well, further optimization is possible. Look at the next, slide we have. So starting from non-pointer version, we try to optimize it, and then further optimization is still possible. So here I'm going to say while star s plus plus is equal to star t plus plus. In the last session, you must have seen this. You must have seen that star t plus plus is going to look at the content of t after the post increment. So This is a shorthand notation for copying each and every content until we reach null. So you need not say s plus plus and t plus plus inside the body of while loop. In this case, I have put semicolon here. So the body of while loop is actually blank. So this is a single line statement for copying the string from t to yes. 2D array of strings is also possible, as I just was mentioning in the beginning of today's discussion. If I look at um, a 2D array of characters like city. So I'm going to look at the max 4 cities. Name of each city can be not more than 12 characters. So the cities can be Chennai, Kolkata, Mumbai, and Delhi, so on and so forth. So inside of memory, they are going to be stored like this. So the ASCII value of C is stored here. ASCII value of H is stored in the next location, so on and so forth. So this is with respect to city of 0. So please note there are a total of 12 columns here, right? Now, after the first city is written here, Chennai, there will be a compulsory \0 null character. That's what we know. After that, the second string must start. Second string is Kolkata. Now, this is going to start from this particular address onwards. So the ASCII value of K is stored, ASCII value of O is stored, and it just continues. The same thing is true for string number 2 and string number 3 as well, like Mumbai and New Delhi. Now, while there is no any problem seemingly with respect to this kind of 2D array of strings, however, I observed that these locations are completely wasted. Ideally, we would love to start the second string Kolkata right after the first string gets over, but that is not happening. It's because of the 2D array of strings. So instead of doing that, if you go for pointers to arrays, that will be a much important difference. Now we have one important quiz coming up. I just want you to answer this particular quiz. Please try to put your comments in the chat box and let's see if you can get this answer or not. So first one is, what is the difference between A and A? Single quote A, double quote A. Okay, answers in the chat box. Single quote A and double quote A. What is the meaning of single quote A? Any answers? Okay, Rakshita says both of them are same. Okay, yeah, people are answering it. Please note both of them are not the same. The first one is a single character. A single character. So when I say single quote A, it corresponds to the ASCII value of character. And if you look at the second case, if I put it in double quotes, this is not just a character. It is a string. That is very crucial. That's right. So there is an implicit null character here, which is not visible. But here there is no any null character at all. I repeat, the first one corresponds to the ASCII value of A or character A. Second one corresponds to a string which has just only one character A followed by a null character which is invisible. So both of them are very different. Now, coming back to the second question, what is the output of this particular program? I have character star str, then str is equal to g, f, g, some kind of initialization I have done. And then I say star str plus 1 is equal to n. So str is going to get me the starting address, and str plus 1, its content is going to get me the next over here. So is it like the content will be g n g or something else? What is the output of this particular code? Any answers in the chat box? Okay, do you have any answer? So will the output be GNG? Okay, Nikhil says so. Nikhil Jain. Any other answer we have? Okay, small GNN. That's what Sangama says. Well, the best way to understand this is to actually, execute it, right? So what I do is I just go to the compiler here, and then let's try to see if it works fine or not. So I'm just going to, okay. So let's see. Okay, so we just try to compile it and then run it. Well, test1.exe has stopped working. So that's what we have, the message over here. Let's see. There is a warning here. The warning is a deprecated conversion from string constant to char star. Well, please note I'm not able to get this output. It is because of the fact that the moment I say char star str, obviously str is a string. I mean str is a pointer to a character. That's what we understand. And when you say str is equal to gfg, str is equal to gfg, I'm trying to initialize it. Now I feel that the output must be gng, capital G and then ng. But what actually happens is such kind of initializations are called string literals. I repeat, string literals. So such kind of literals are stored in memory, in the part where you cannot actually modify those contents. So in the read only part of memory. So that part of memory is used for allocating such string literals, space for such literals. So the moment I say star of str plus 1 is equal to n, so I expect this to be replaced with n instead of f, but that is not going to happen because we're trying to change the contents in a read-only part of memory, and hence this kind of operation is not allowed. So this is very, very important. Okay. So do we have any questions further? Because we want to stop at this for day 2 and then once again continue. So any questions quickly from whatever we have covered in today's discussion? Okay, a very simple question I'm going to ask you, just to understand a couple of points more. Is it possible for me to actually have a double pointer as a loop index variable? Is it possible for me to have a double pointer as the loop index variable? Answers in the chat box. Yes or no? Shweta says no. Okay. Any other response? Please note that it is possible. Please note that it is possible for us to have it. What can be a possible reason for us to have a loop index variable? I'll just show you one example where we had actually done it. So if you just go back, okay, okay. Well, if you consider this example, we just have not this example. I'll just go through it once again. Okay, okay. Let's see if it is possible for you to replace this while statement in the for statement with the appropriate syntax. You would still want to find some kind of length of a string or copy the contents of string, so on and so forth. So what happens is, if you say star t, this is like the contents of t. Now if I have a pointer which points to another pointer, that means a double pointer, and if the first pointer points to a string, then it is always possible for me to have something like star t not equal to null, and hence I can have the body of a while loop or for loop or any other kind of loop. So please note, it is possible for me to have a double pointer as a loop index. It is very much possible. Okay. One more question let's try to answer, and then I think almost we'll close for the day. Now, is it possible to have uh, typecasting of typecasting of a null pointer? Yes or no? Is it possible for us to have a typecasting of null pointer? Is it possible? The null pointer? Okay, Nikhil says yes. Typecasting of null pointer. Rachita says yes. Do we have more responses? Okay, Shweta says no. Please note that the answer is no. So please distinguish between a null pointer, null value, and let's say a void pointer. I can always, I can always, typecast a void pointer, but not a null pointer or null value. I cannot do that. So I repeat once again, it's possible for us to typecast a void pointer or a generic pointer, but it is not possible for us to typecast null or null pointer, because a null pointer simply means that I have a pointer which is pointing to no valid location. It's pointing to nothing. So from that perspective, you should be very careful. Okay. So do we have any other questions here in the chat box? Okay. So if there are no more questions, then I think I'll hand over the session to Professor Kotesh, sir.
Thank you, sir. So hope it was a sir. It was a very nice, informative session on pointers and strings. So, students, tomorrow we'll meet at sharp 10:30 a.m. Again, we'll send you the link. Before winding up, there is a small message from Dean C. Triple I. So, your
Hello, Kotresh. Hello, Kotresh.
Hello. Hello.
Yeah, can you repeat
Yeah.
the contents once
Yeah.
again?
Yeah.
Because we.
Okay. Okay. Okay, sir. Sorry. Dear students, there is a information message from Dean CIII. It is hereby informed to all the students to take the exam compulsory on July
Yeah.
29th. The students are requested to log in to the iusupport.in, and you are supposed to take the examination, and this examination will be a benchmark for your placement, coming placement activities. So by today evening, you are supposed to take the exam, and this exam is mandatory to all the students who have taken the exam already. So you can neglect this, but those students who have not taken this exam, they are supposed to take this exam compulsorily. Okay, I repeat once again, it is iusupport.in. Okay, thank you. We'll meet tomorrow sharp at 10:30 a.m. Tomorrow's
Thank you.
session will be on once again continued portion of pointers. Okay, thank you very much.
Thank you so much. Thank you.
Okay, thank you, sir.
Thank you, Kotresh. Thank you. Vandana Mishri.
Yes, sir.
Broadcast ಮುಗಿತೇನ್ರಿ?
No, sir. I'll just end this.
Okay.